Video registration is having a reference image, you can see it on your left side, and having a whole video of a non-rigid deforming object. We would like to register each pixel of the non-rigidly deforming object of that video to the reference image, and we would like to be stable to disturbing effects like occlusions, even large occlusions. So, how we are doing that? There are state-of-the-art multi-frame optical flow methods that can already quite accurately compute correspondences for non-rigidly deforming objects. However, in the case of occlusions, especially large occlusions and large specular reflections and other disturbing effects, these correspondences are disturbed. We come up with a solution that is a lot less disturbed by these effects. So how we are doing that? We are computing the correspondences using a multi-frame optical flow method with subspace constraints. We use then these first partly wrong correspondences in this in the occlusion area regions, and then we assign a probability of each to x pixel being occluded or visible. So we come up with an occlusion map in a probabilistic way. How are we doing that? We take a state preservation model to compute the probability, in addition with a control variable input that counts the overlapping correspondences, and we take a so-called measurement model in this predictor corrector method that takes the variance of the divergence of these correspondences over a patch. And then we have this basically concludes our stage 2 and gives us an approximation that is temporally and spatially somehow coherent already. We globally smooth that in space and time to obtain the final stage 3, so the final occlusion probability map. Having this probability map for each image in the video with respect to the reference image, that tells us something about how likely it is that this part of the object is occluded. We take this probability map and come up with a new occlusion-aware multi-frame optical flow method, which uses this probability map, and solves this energy that you can see here, alternatively with subspace constraints and these trajectories throughout the whole video, and solves it with handling the constraint that if the probability of a pixel being occluded is larger than a threshold, here 0.5, then we restrict the correspondence search to the subspace constraint that are computed. With that, we can correct the correspondences and have, even for non-rigidly deforming objects in occluded areas, quite accurate results. We compared that to other methods, the previous multi-frame optical flow method and state-of-the-art two-frame optical flow method that handle occlusions, and obtain a better endpoint error that you can see here. How can we apply that? Here you can see an application to non-rigid structure for motion. You can see on the right on the top row on the right, you can see the probability map that you can also interpret as an uncertainty map of correspondences, which gives a lot more additional information for the correspondence search. And the correspondence computation in the non-rigidly deforming areas are quite accurate, as you can see in the lower left row. Here is a much more challenging example of a beating heart during a bypass surgery. You can see large moving reflections, and on the top row you can also see that a robot arm is entering the scene. And the correction that we propose actually stabilizes the non-rigid reconstruction that you can see on the bottom line already a lot.